Alright, Chapter 4, Mechanisms, Part 1 of 2. The following questions will be answered. What is a mechanism? What are the different types of linkage systems? What is the purpose of the cam and follower? What are the different types of bearings that are used in mechanical devices? What is a gear and what conditions must be satisfied for two gears to mesh properly? What are the most common types of gears? What is the difference between a simple and compound gear train? And what components make up a chain drive mechanism? Linkages. A linkage is an assembly of rigid mechanical components within a mechanism that are linked together for the purpose of transmitting force and controlling motion. Linkage systems are incorporated by mechanical engineers into the design of industrial equipment, tools, and their inner workings of commercial products. In machines, linkage systems are often used to change rotary motion into linear motion and vice versa. Large clamping forces can be generated by linkages, which is why they are used in tools such as toggle clamps and locking pliers. Linkage, a 4-bar linkage. A 4-bar linkage consists of 3 movable bars, 2 pivot joints, and 2 pin joints. The 4th bar is a fixed structure, such as a machine's rigid framework, that provides the connection to the fixed pivot points. A parallel linkage is a type of 4-bar linkage system that follows the geometry of a parallelogram. A variation of the parallel linkage is the scissor linkage. Slider crank. This linkage system is used to convert reciprocating linear motion into continuous rotary motion or vice versa. A crank is a bar that has one fixed pivot point. A crank can rotate 360 degrees. This kind of mechanism is found in piston-type internal combustion engines. Cam and follower. A slider crank linkage mechanism is used to change the continuous rotary motion of a crank into reciprocating linear motion of a slider and vice versa. The cam serves as the rotating component which makes contact with the follower. There are several types of cam and follower mechanisms, but the simplest and most common is the plate cam. This plate is made from a flat piece of rigid material that is cut to a specific shape called a cam profile. An engineer will first create a cam displacement diagram to show the timing and motion of the follower. The most widely recognized and continued use of the cam and follower occurs within the piston-type internal combustion engine. Cam-type clamping mechanisms are used on manufacturing fixtures to hold parts in place during machine operations. Bearings. A bearing is a mechanical device that is used to reduce friction where two surfaces meet and slide against each other as a result of rotary motion. Linear motion bearings. Linear motion bearings apply to situations in which one component must slide along another in one direction. A plain bearing may be called a sleeve, bushing, or journal bearing. Rotary motion bearings. Rotary motion bearings are designed to interface with rotating shafts. Radial load bearings and thrust bearings are two commonly used devices that fall under this category. Bearings require lubrication unless the inner components are sealed. Radial load bearings are used when a rotating shaft must be supported by a fixed structure. Some shafts generate axial forces as well as radial loads. Gears. Gears are used to control rotational direction, rotational speed, and torque in mechanical systems that involve precisely controlled rotary motion. Gears give us the ability to precisely control the output of a motor or engine by decreasing speed and increasing torque to more appropriate and useful levels. Basic gear geometry. A gear is a toothed wheel that is used to transmit rotary motion and torque from one shaft to another. Gears have specially designed teeth that are defined by a mathematical curve called an involute curve. As the gear teeth move past each other, the point of contact will move along an imaginary line of contact. The angle that defines the slope of the line of contact is called the pressure angle. Pitch circle is an imaginary circle around which the teeth on a gear or any other uniformly toothed device are evenly spaced. The size of a gear tooth is determined by the number of teeth that occur in 1 inch of arc length along the pitch circle. A gear that has a large diametrical pitch will have smaller teeth than a gear that has a small diametrical pitch value. 3 rules for spur gears in mesh. Only gear teeth are based on the same pressure angle will be able to mesh properly. Only when the pitch circles of mating gears are tangent to each other will the gears be able to mesh properly. Only gear teeth with the same diametrical pitch value will be able to mesh properly. Gear types. Aside from the external spur gear, other gears that might work with include you might work with include the internal spur gear, helical gear, bevel gear, and the worm and wheel. Helical gears. A helical gear is similar to an external spur gear, except that the teeth wrap around the gear hub in the form of a helix. One of the disadvantages of a helical gear is the formation of end thrust. It makes the gears slip past each other in opposite directions if the shafts are not securely held in place. The gear shafts must be to counteract this tendency. Worm and wheel. This is a gear that have non-parallel and non-intersecting shafts. A worm is a screw thread that shares similar geometric features of the gear. It takes one full revolution of the worm to rotate the wheel only one tooth distance. It is frequently used in devices that are capable of precise angle calibration, such as a rotary table used in the machining industry. Straight tooth bevel gear. Bevel gears are gears that are non-parallel but intersecting shaft gears. Bevel gear teeth taper as they draw closer to the apex of the gear cone. Bevel gears must be designed in pairs. Rack and pinion. Consists of spur gears that interface with a flat bar into which straight gear teeth have been cut. This tool is used to force pulleys onto shafts or pins and bearings into holes where interference fit must occur. Gear trains. A gear train is two or more gears in mesh that are used to increase or decrease rotational speed and torque and change or maintain rotational direction between the input and output systems of a mechanical system. A simple gear train is two or more gears in mesh that have only one gear per shaft. A compound gear train is a gear train that has at least one idler gear shaft that carries two gears of different size that rotate at the same speed. This ends part 1.